Section 5.7, Example 3 says a biologist is studying the deer populations in 2 state parks. She projects that the population in Park A in X years will be modeled by A of X equals 200 plus 25X, and the population in Park B in X years will be modeled by B of X equals 100 times 1.05 to the X power plus 40. What is a function giving the projection for the total population of deer in both state parks? Use the function to predict the total deer population in 4 years. When it says the total deer population in both state parks, we're talking about A of X and B of X, so we are going to add these two together. Since we're looking for A plus B of X, we're going to take A of X and add it to B of X. We know that A of X is 200 plus 25X, and B of X is 100 times 1.05 to the X power plus 40. Since we're adding, we can go ahead and get rid of the parentheses, and now we want to look for some like terms. Notice we have a 200 that's all by itself, that's just a constant, and we have a 40 all by itself, which is also just a constant. I know this 100 may look like it's a constant, but notice it's got times 1.05x. So this entire piece right here is actually one term. So the 100 is not a constant. It's saying we have 100 of these 1.05 to the x powers. So this is one big term. We can't combine it with the 200 and the 40. The 25x is the only term that's got an x being multiplied by something. Again, this x up here is in the exponent, so these two are not like terms. They look very different. This has a variable in the exponent, this has a variable just down next to the 25. So the 25x and the 100 times 1.05 to the x power don't have any like terms, so we leave them just the way they are. I'm going to go ahead and write the 100 times 1.05 to the x power first, then I'm going to put plus 25x, and then we've got 240, that becomes plus 240. So this is A plus B of x without plugging anything else in. The very last part of this problem says use the function to predict the total deer population in 4 years. So all we're going to do is instead of writing x, we're going to plug in a 4 every time we see x. When we plug in 4 for every single x, we'll start with our exponent. So 1.05 to the 4th power gives us about 1.22. Notice that my equal sign turned into an approximation because this value right here is actually a very long decimal, and we're going to round to the nearest 2 decimals. So all of my following symbols are going to be approximations. So 100 times 1.22 gives us 122. 25 times 4 gave us 100, so 100 plus 240 is now 340, and now we just add 122 plus 340 to get 462. This tells us that 4 years from now, there will be about 462 total deer in both parks. The work for this problem is all written out on the next slide. And now I would like you to try number 5 on page 340. The cost of manufacturing X t-shirts is modeled by the function T of X equals 5X plus 12, and the cost of manufacturing X sweatshirts is modeled by S of X equals 15X plus 18. What is a function giving the total cost of manufacturing t-shirts and sweatshirts? Find the total cost of manufacturing 15 t-shirts and 15 sweatshirts.